Hello everyone, I'm Miss H, and today we're going to be looking at properties of matter. So properties of matter fall into two primary categories. The first of these categories are chemical properties. Chemical properties are properties of matter that require a chemical change in order to observe or measure them. During a chemical change, the chemical composition of the substance changes. So you start with one substance and end with something that's different than that. Some examples of chemical changes include digestion, rusting, burning, and exploding. In all of these, you can see that what you start with is different than what you end with. So the food that goes in your mouth is different than what comes out the other end. When something rusts, it doesn't just change color, it actually changes from one material to another. For example, a car rusting changes from iron to iron oxide, and that's why not only does the color change, but also the texture changes and the chemical properties change. Same thing with burning. You start with something and you end with ash, and that you can't undo that very easily. And in fact, most chemical changes cannot be easily undone. They require another chemical change in order to undo them. So how do you know that a chemical change has occurred? Because it doesn't always look different. So sometimes it will look, smell, or taste different. Now remember that in a lab, you never want to smell or taste anything unless you are explicitly told to do so. So again, never taste or smell anything unless you are explicitly told to do so, but it's a great indicator of a chemical change happening when you're doing something like cooking or baking. That's why the smell of cookies changes in the oven from the cookie dough. Change in color can also be a sign that a chemical change has occurred, such as with rusting or oxidizing rather, like what happened with the Statue of Liberty. Used to be the copper color, and that copper has oxidized, and now it's the green color. You can also have the formation of a gas or the formation of a precipitate. A precipitate is a term that we use in chemistry that just means it's a solid. So if you add two liquids together and you end up with a solid at the bottom, in addition to some liquid usually, then that means that a chemical change has occurred. Additionally, you can have the giving off or absorbing of energy. So light would be produced, or you would have a change in temperature. Now, any of these taken alone may or may not actually be a sign that a chemical change has occurred. For example, it is possible to have a change in temperature without having a chemical change occur. The second category of properties of matter are physical properties. These are things that can be observed or measured pretty much any time. So these are the things that we typically think of when we think of properties of matter. They can include things like mass and volume that we can measure with a balance or a graduated cylinder or by calculating length times width times height. It can include things like density, color, shape, odor, texture. Again, all of those things that we typically think of when we start describing something. Physical properties are broken into two categories. The first are intensive physical properties, and these do not change based on the amount of material present. This would include things like color and odor. So it doesn't matter whether I have 1 gram of steel or 10 grams of steel or 100 grams of steel, it's always going to look the same. It doesn't matter if I have 1 gram of sulfur or 100 grams of sulfur, it's still going to smell like rotten eggs and it's still going to be yellow. Extensive physical properties vary based on the amount of material present, so this includes things like mass and volume. So looking at the example we just did, I talked about the mass of the steel or the mass of the sulfur. That was how many grams it was. So that's going to be different based on how big the sample is. The volume is the same way. Volume is going to change based on the amount of sample present. So these are properties that are going to change, but are also predictable, and we'll talk more about that in just a minute. During physical changes, only the appearance of the substance changes. The chemical composition remains exactly the same. So if I have an ice cube, we know that water is H2O. When that H2O is in its solid state, we call it ice. If it melts and becomes a puddle of liquid water, it's still H2O. It just went from being a solid to a liquid. It looks different. And it is going to behave a little different, but again, that's something we'll get into more later. So melting is a physical change because, again, only the way that the water looks has changed. It hasn't actually changed from H2O to something else. We're going to kind of focus on the physical properties here. There are going to be other videos that focus on the chemical properties, and there are 3 physical properties in particular that we want to focus on. The first of these 3 is mass. Mass is how much matter or stuff makes up a substance. So if we wanted to describe mass in one word, we could use the word stuff. The unit for mass is some form of the unit grams. In Unit 1, we'll typically use grams, and later units will typically use kilograms. But again, it can be grams, kilograms, milligrams, any of those sorts of things, as long as it is some form of gram. And the variable for mass, when we put it into a formula, is a lowercase m. The second physical property we want to focus on is volume. Volume is how much space a substance occupies, or thinking about it, how big or small the substance is. So one word to describe volume would be space. How much space does it take up? The unit for volume in this unit will typically be milliliters or cubic centimeters, but it could also be liters, kiloliters, cubic meters, cubic kilometers, those sorts of things as well. Again, as long as it has some of that form in there. 1 milliliter is the equivalent of 1 cubic centimeter, so you can use those units interchangeably. You can see milliliters written as ml. Cubic centimeters will either be written as cm to the third or ccm for cubic centimeters. When you listen to or watch like medical drama shows, and they'll say, you know, I need 10 cc stat, what they're saying is I need 10 cubic centimeters or 10 milliliters of that particular thing very quickly. The variable for volume in a formula is a capital V. Everything that exists as matter, anything that exists as matter is made up of, that should say mass rather, is made up of, or everything that exists is made up of matter and takes up space. So everything that is matter has mass and takes up space. And for the purposes of an introductory physical science class, we can divide things into either matter or energy. So if it's not energy, it's matter for the purposes of a introduction physical science class. The other property we want to focus on is density. Density is a measure of how compact something is, or a ratio of its mass to its volume. So we're going to look at how does the mass of the substance compare to the volume of the substance, and that's going to help us to figure out how compact it is. One word to describe density would be compactness. So the more compact something is, the denser it is. The unit for density will be some version of a mass unit over some version of a volume unit. So again, in Unit 1 for physical science, we'll typically be looking at either grams per milliliter or grams per cubic centimeter. But again, this could also be something like kilograms per square meter or kilograms per liter, those sorts of things as well. The variable for density in a formula is a capital D. And there is another video that I have posted all about how to calculate mass, volume, and density. So I'm not going to go into that here, but you can watch the video on mass, volume, and density for more information on those calculations. When comparing the density of two objects, we have to include both the mass and the volume because density is more than just mass or volume. It is looking at the ratio of those two together. So if we were to compare the densities of these boxes, we have to look at both how big they are and how much stuff they contain. So if we compare the volume of box A and box B, box A and B have the same volume, but B has more dots or more matter, more mass. So B is denser than A. I think of it as how crowded the room is. So the more crowded the room is, the denser the object is. If we compare boxes A and C, they have the same mass, but box A is significantly smaller than box C, so box A will have the higher density because it is more crowded, it is more compact. The other one that we need to talk about with density is a density column. So a density column is where you have liquids that are added to a column of water, such as a graduated cylinder, and they will separate based on their density, with the densest liquid going to the bottom and the least dense liquid going to the top. You can also include solid objects in density columns, and they will settle in between the liquids that they are in between the densities of. I hope that this has helped you better understand properties of matter. If you have any questions, don't hesitate to leave them in the comments below.